Hello, good day. I am Brando A. Pinheiro. I'm going to discuss the difference between one-way ANOVA versus two-way ANOVA. So before that, what first is ANOVA? When we say ANOVA, ANOVA is short for analysis of variance. This is used to determine whether or not there is a statistical significant difference between the means of three or more independent groups. The two most common types of ANOVAs are one-way ANOVA and the two-way ANOVA. So let us differentiate between these two ANOVAs. Now, in one-way ANOVA, also known as one factor accounted for. Hypothesis test, only one categorical or single factor is considered, and comparison of means of three or more samples. And then um, finds difference among different categories which have several possible values. And the null hypothesis is equally in all population means. And the alternative hypothesis will be the difference in at least one mean. However, in two-way ANOVA, there are two factors investigated concurrently. The hypothesis test, wherein the classification data is based on two factors. And then it used to compare several levels, or also known as conditions, of the two independent variables involving multiple observations at each level. And it examines the effect of the two factors on the continuous dependent variable. For example, ANOVA. Um, in one way ANOVA, it may be gender has influence in inflation, or group of foods has influence on the blood pressure, or um, the science subjects has influence to students' performance. Now, there are assumptions of one-way ANOVA. One-way analysis of variance makes three assumptions about dependent variable scores. First is the independence. The dependent variable score for each experimental unit is independent of the score for any other unit. And the normality in the population, dependent variable scores are normally distributed within treatment groups. In equality of variance in the population, the variance of dependent variable scores in each treatment group is equal, or equality of variance is also known as the homogeneity of variance or homozydicity. Now, there are also assumptions of two-way ANOVA. First, the normal distribution of the population from which the samples are drawn. Next is measurement of dependent variable at continuous level. And there are two or more categorical independent groups in two factors. The categorical independent groups should have the same size and independence of observations. And it can be observed the homogeneity of the variance of the population. Now, this is an example of the two-way ANOVA. For example, is gender has influence on the blood pressure, or the group of uh, foods has influence to the blood pressure. And then these two independent variables, the gender and group of foods, may have interaction effect if this is a two-way ANOVA. Now, to summarize the difference between one-way and two-way ANOVA, let us see the table. Now, first is the meaning of the two ANOVAs. One-way ANOVA is a hypothesis test used to test the equality of three or more population means simultaneously using variance. In two-way ANOVA is a statistical technique wherein the interaction between factors influencing variable can be studied. Now, about independent variable, in one-way ANOVA, there is only one independent variable. In two-way ANOVA, there is two independent variables. So when comparing, there are three of more levels of one factor under one-way ANOVA. In two-way ANOVA, effect of multiple level of two factors. The number of observation under one-way ANOVA, it needs not to be the same in each group, while in two-way ANOVA, which is different from one-way ANOVA, need to be equal in each group. Now, the design of experiments need in one-way ANOVA, it needs to satisfy two principles. In two-way ANOVA, all three principles needs to satisfy. So let us have an example problem involving one-way ANOVA. And let us analyze the problem with the given data using Jamovie. So the problem goes this way. A mathematics instructor is interested in evaluating the academic performance of grade 11 students in statistics and probability, pre-calculus, and basic calculus from a sample of 33 STEM students in a selected class. To assess whether there are significant difference in the mean grades among these subjects, the teacher employs one-factor analysis of variance. So to analyze or to assess whether there is significant difference in the mean grades among the three subjects, um, we need to know the significant difference by knowing the p-value and compare the p-value to the alpha value, which is um, the usual alpha value is 0.05. Now, the condition here, if the p value is less than alpha value, then there is significant difference. However, if p value is greater than or equal to alpha value, then there is no significant difference. These are the performances of 33 students on their three subjects, statistics and probability, pre-calculus, and basic calculus. So let us use Jamovie to assess whether there are significant differences in the mean grades among these three subjects when one-factor analysis of variance is employed. So let us open Jamovie application. I have opened the Jamovie. So let us start. Let us open the data by clicking this one and click open. And since I save already this data in Excel, so I save the data in CSV file type. So by clicking this, then we have two columns. So first column are the three subjects, statistics and probability, pre-calculus, and the basic calculus. So there are 99 uh, that is 99 grades since there are 33 students and three subjects. Uh, or in the first column, we have the subjects, and the second column are the grades. So each subject has three respondents or 33 students. So the first 33 are for statistics and probability, and the second 33 are for pre-calculus performance, students' performance, and the remaining 33 are the performances under basic calculus. So first is let us see the summary of data in each group with the importance to statistical measures. Now to do that, just click exploration and then descriptives, and let us but make sure first that grades is in continuous and it that data type is integer. Then click this one. Let us go back. Now, to see the variables here are the grades. So let us transfer grades under variables by clicking this arrow. And then we will split into by grades by clicking these grades and this arrow. Okay. So here the sample can be seen in basic calculus, pre-calculus, statistics, and probability are all 33 samples. And all subjects are zero missing. And the mean can also be seen here, the median in each subject, standard deviation, the minimum and the maximum performances of the three subjects. To add more statistical measures, just click statistics. And then, for example, if we need to add variance, then in this under dispersion, we will click variance. So here in descriptive table, there's additional variance. In basic calculus, 38.5, 30.6, 26.64. Now, if we need to add the range, then click range, and then it is added here, added by range. So each subject as, for example, basic calculus has range of 24. The range is obtained by highest value minus the lowest value. So pre-calculus has 21 and statistics probability. Now in mean dispersion, so you can click the standard error of mean. In each subject, there is standard error mean and the and so on. The distribution, you can also click skewness of each subject. To employ ANOVA, one-way ANOVA, just click ANOVA and then click one-way ANOVA. So we will place grades under dependent variable and then subjects under grouping variable. And let us see the results. So as you can see in one-way ANOVA, let us use features. This is the usual variances that is being used and then just uncheck, don't assume equal or the Welch variances. So as you can see, the degrees of freedom is 2 and the difference 96. And the p-value is 0.571. So here it is clear that the p-value, which is 0.771, is greater than the value, the alpha value. Therefore, there is no significant difference between the means of uh, the mean grades among the three subjects when we employ one-way ANOVA. So let us proceed to two-way ANOVA example problem. Now, the problem goes this way. 30 mathematics students were randomly assigned to one of the three instructors and to one of the two methods of teaching. Achievement was measured on a 50-item test administered at the end of the term. So there are two methods of teaching, teaching one and teaching two, and there are uh, three instructors. You have instructor A, instructor B, and instructor C. Now, the problem here is there significant difference in the performance students under the three different teachers? And problem two is there significant difference in the performance of students under the two different methods of teaching? And problem three is there interaction effect between teacher and method of teaching factors? So the hypothesis here for problem one, the null hypothesis, there is no significant difference in the performance of the three groups of students under the different teachers. The alternative hypothesis, there is a significant difference in the performance of the three groups of students under the three different teachers. Now, for hypothesis of problem two, the null hypothesis, there is no significant difference in the performance of the three groups of students under the two different methods of teaching. The alternative hypothesis here, there is significant difference in the performance of the three groups of students under the two different methods of teaching. And the hypothesis for problem number three, the null hypothesis, interaction effects are not present, and the alternative hypothesis, interaction effects are present. So how are we going to decide? There must be a decision rule. So if the p-value is less than or equal to 0.05, the alpha value, then we need to reject the null hypothesis and accept the alternative hypothesis. Otherwise, if the p-value is greater than 0.05, we need to accept the null hypothesis. We'll be using a Jamovie software to analyze and to answer the problems of this problem. So let us open the Jamovie software. We have opened the Jamovie software. So we need to open the data which is uh, saved in Excel and in CSV file type. So let us check the p-values and check if there is interaction between two independent variables. So to do that, we need to click ANOVA. Anyway, we have here the data. One here represents the first teaching method or the method teaching one. And then the two here in the first column represents the method of teaching two. And then the A's here under second column are for its first instructor or instructor A, and then second instructor for B, and then C for the third instructor. And here are the scores in every method and in under and in every instructor. Okay. Now scores must be in integer type, or the data type of scores must be integer. So we'll go back. So this method and instructors are the independent variable. Now let us now test the p-value and if there's interaction between the two independent variables, the method and the instructors. Now to do that, click ANOVA, then click again ANOVA, and then we need to place scores under dependent variable. And then the fixed factors must be the method and the instructors. And we have here the results of two-way ANOVA. So let us interpret and analyze. So we can now answer those three problems. In the first problem, as you can see, the p-value is greater than 0.05 or the alpha value. Then there is no significant difference in the performance of three groups of students under the three different instructors. And for question or problem number two, it's less than the alpha value, therefore there is significant difference in performance of students under the two different methods. Now, to answer problem number three about interaction, as you can see, it's also less than the alpha value. Then, therefore, there is um, interaction effect between the instructors and the method of teaching. So that's how are you going to use Jamovie in employing two-way ANOVA.